Thanks for joining our webinar today. We're going to be covering 3D scan to CAD tips and tricks. We're going to have some folks from the team at Geomagic on the line helping us out, as well as our team here at 3DChimera. Thank you guys for taking time out of your busy day to join our session. So on the line, we've got Jeffrey Moody, a software applications engineer at 3D Systems. He's going to be doing a live demo for us here shortly. And myself, Alex Hussain, I'm the co-founder and CEO here at 3DChimera. I want to let you guys know any questions that you have, you can raise a hand at any time or shoot your information over in the system with questions, and we'll be happy to assist you with that. I know some folks were having some login issues earlier, so we think we've got that all straightened out here, but we will be sending out a recording to any folks that had trouble logging in. So with that said here, I'll want to give you guys a brief introduction about 3DChimera. I know that most of the folks on the line already know us. We've probably connected over email or something to get you guys to join the session here, but for those of you maybe who had the invitation shared or who are sharing the video, 3DChimera is an organization based down in Miami, Florida. We specialize in 3D printing and 3D scanning. We provide equipment to our customers. We do engineering and design consulting services. We also have 3D printing and scanning services here as well. And we do quite a bit of R&D in this space as well. We are a small team, but we're very proud. We were just recently recognized as one of the top 10 3D printing consulting companies in the United States this year. We work with a variety of partners to help our customers solve their 3D scanning and 3D printing challenges. On the 3D printing side, we work with German RepRap 3D printers from their FDM printers. We work with Sintertech, which is an SLS 3D printer. On the 3D scanning side, we're working primarily with the HP 3D scanners, which you'll hear quite a bit about today. From the 3D printing side, again, we work with Dow and DuPont, particularly on new material development. And of course, we work with ANSYS as well as Geomagic for doing reverse engineering and working with the scan data. So that's really our topic today, focusing on the workflow from 3D scan to CAD. So I wanted to put out a quick poll here for everyone who's attending. And if you guys can just fill this out, it would be super helpful. Basically, we're trying to learn a little bit about your experience with 3D scanning, if you own a 3D scanner or not, and your general experience level with Solidworks. Okay, we'll just give that a couple more seconds here. Okay, great. We'll go ahead and close that. So it looks like we've got a mixed bag of folks with experience using 3D scanning. So some that use it very often, some that are just getting started. In addition, it seems like everybody is a pretty strong SolidWorks user, which is fantastic. I think that makes a lot of sense for our session today. So great, perfect. So the first thing for folks who are not using 3D scanning is that it's important to note that 3D scanners are not some type of a magical tool that is able to just like copy something and help you replicate it in the future. It's for sure a tool, but it's a digitizing tool. It does require a skilled operator and really careful planning to get the type of results that you're trying to achieve with the scanner. So, a lot of times when people are first starting with scanning, they're surprised to learn the number of steps. And I think for folks who are using 3D scanning, it can often be a mixed bag of, a lot of steps that might seem challenging, but we're hoping that as you learn today, there are tools out there to make things easier. Our favorite tool is Geomagic, and we'll spend quite a bit of time highlighting that today. So when you're working with the 3D scanner, the most notable thing is that the data that you create is not similar or even in the same sort of digital formats that you typically work with in CAD. Um, and when I say CAD, I'm really referring to like mechanical CAD systems, something like SolidWorks, Pro Engineer, Autodesk Inventor, something along those lines. Commonly, 3D scanned objects are going to produce a mesh data straight out of the scanner. So if we look at this image on the screen here, that's going to be like the images on the left-hand side. They look like CAD, we can spin them around, but as you zoom in, you'll notice that the surfaces are made of lots of little triangles. Now, there are some CAD systems that can import STLs, but one of the most common CAD systems that people work with is going to be SolidWorks. And what we find is that when you import an STL into SolidWorks, it can be really challenging to work with that data and to get the type of results that people need. And so we have a couple of different techniques that we use in order to try and work with that data. The first is starting at the top here is just simply working with the mesh data to clean it up. And from there, you might do something like send the file to a 3D printer or send the file to do finite element analysis, something along those lines. In that case, we're not really doing any type of actual work with the data. We're just simply processing the mesh data. As we move on, we have options for full reverse engineering in the center. So this is what we consider design intent based engineering work. Here we're going to be pulling out reference planes, creating actual features to work with the model. And then finally, we have perhaps a more low effort way to manage the data, and that is our exact surfacing methodology. This is a little bit more automatic. In a lot of ways, it's what a lot of our customers are thinking about when they ask to be able to open a scan file inside of a CAD system. They're essentially asking for some type of a step file or model that you can open. And this exact surfacing methodology is a great way to do that. It's going to give you reference features inside your model where you can cut holes, you can create cross-sectional planes, and you can really work with the data. So when we think of the 3D scan process, we try to simplify it even further. First, we think of it as data acquisition. That's just capturing the data with the scanner. Then secondarily, we think of these next two steps as post-processing. So within that, you have data preparation. That's kind of like cleaning up your scan data, maybe filling in holes or removing noise from the scan data. And then your mechanical design work. And that's really the meat and potatoes of the 3D scanning world. That's what people are trying to do with the data, whether you're trying to create a reference model to build a new object or trying to reverse engineer an object that perhaps is obsolete. That's really, I think, where folks kind of meet their biggest challenges, particularly working with SolidWorks, and where Geomagic for SolidWorks really excels. So before we jump into that too far, I do want to go over a little bit about 3D scanners. So in general, there are three typical form factors for 3D scanners. There are tripod-based scanners, ARM-based scanners, and handheld-based scanners. We're going to focus on a tripod-based scanner from HP. There are also a number of different technologies underlying. You have structured light, laser scanners, photogrammetry, and probing, which is like a manual touch process. We're going to be talking about structured light. So structured light projects like a pattern on an object and uses a series of projectors and cameras to interpret that pattern on the object and extrapolate 3D data. What's really cool about this process is it's also able to be easily paired with color data. And so most scanners that are working with structured light are also able to work with color. So the scanner we're going to be talking about today is the HP scanner. So this is a little bit of information about it. I'm sure that many folks on the line here actually already use this scanner. It's a really nice system because it's able to be very flexible. We say you can scan anything from a coin to a couch with this system. And that's because if you look at the scanner on the left-hand side there, you'll notice there's a projector and cameras on what appears to be a rail. And it actually is a rail. what we're able to do is slide those cameras on the rail and change the field of view, which is what allows you to focus on either very small objects or very large objects. Most 3D scanners on the market have a fixed relationship between the projector and the camera, and therefore are unable to scan a broad range of objects. So we really like this scanner. It's been our scanner of choice for a number of years now. So you can see some examples here of objects that have been scanned with the HP scanner. So everything from a bone plate on the upper left-hand corner to a sheet metal mold for a really highly complex model on the upper right-hand side, to an oil bottle that was actually about ready to go into production state in a new location where CAD data is missing, to reference model of an actual bone part, so that you're able to design mating features or even faces or people. So as we think about how you work with this data and how you are able to transition from the 3D scan software into your CAD system, folks often kind of get hung up. And this is where Geomagic for Solidworks comes in. So this is a plugin that works with Solidworks, and it allows you to actually create feature-based models. It allows you to work with the scan data, repair any issues you might see in the meshes, and create those auto-generated surfaces we talked about. You're able to work right in the native SolidWorks environment. So if you're looking to create reference data that you're able to build upon, you can do that. Likewise, if you're looking to work with data that you can simply use as a reference, you can do that as well. So it's really a fantastic tool. We find that with our customers who use SolidWorks, this tends to be their preferred methodology, because it allows you to keep everything in a central place as you're doing your modeling work. So an example of something that can be done using these tools here, this is just a bottle scan on the left-hand side. You can see what a feature-based parametric model on the right-hand side starts to look like, more like our traditional CAD models that you might build from scratch. So with that said, I want to transition this over to a live demonstration here. And so I'm going to go ahead and pass control over to Jeffrey.
All righty. Thank you, Alex. Just let me know if you can hear me well enough, and I'm going to go ahead and switch my screen over.
Yeah, we can hear you great.
Perfect. Can you see my screen okay?
I haven't seen it come through yet. Give me just a moment. Yep, there we go.
Okay. So thank you, Alex. Once again, my name is Jeff Moody. I'm an applications engineer with 3D Systems Software. And today we're going to be talking about Geomagic for SolidWorks. Geomagic for SolidWorks is a standalone plugin inside SolidWorks, like we were talking about earlier. And it's a left to right workflow. So it's kind of a linear workflow, starting with import, moving into mesh processing options, moving into some sort of alignment, maybe a little bit more mesh processing, such as hole filling or repairing the mesh itself if the need arises, and then putting down reference things or getting it to the global origin. So today we're going to be talking about two workflows. Like we were talking about earlier, we're going to do an exact surfacing workflow, basically putting down a NURB surface on a mesh model and then using it to create some cuts or things like that. Then the second workflow we're going to talk about is prismatic reverse engineering. So I'm going to go ahead and go up to the import option on the left. Then I'm going to select the vertebrae. And we're actually going to do the NURB surfacing first. This is a part of a spinal column that we scanned, and you can see this is a really good mesh. This is kind of the quality of mesh you can get out of the HP scanner, as Alex was saying earlier. But just to make sure that there's no issues that I can NURB surface this correctly, I'm going to go up to my plugin and I'm going to select repair. What the repair does is take a look at intersections, non-manifold edges, all these sorts of issues, and when I hit diagnose mesh, it'll highlight those issues for us. And here you can see it's found 3 spiked edges and 249 spiked vertices. And in fact, if I look around on my model, we can see that it highlights it red, or it did. There we go. So it's kind of inside there, right about here. And when I hit OK, it's going to attempt to correct all those issues. So this will take just a second, and then once it's done, we should see that this is now a manifold mesh with no holes or no issues, which will allow us to auto surface it correctly. Perfect. Now I'll come up to the auto surface option in Geomagic for SolidWorks, and then I'm just going to change a few settings here. Instead of mechanical, this is kind of an organic object, so I'm going to select organic, and I want my target count, or my target patch count, to be around 100. If I set it on auto estimate, it would give us a better definition of this model, but SolidWorks may have a hard time handling something larger than 500 patches. So now I'm going to go ahead and say OK to that, and it's going to create the auto surface. And what we're going to see here is a bunch of different surfaces that are set on top of this mesh to describe the part. It's going to look kind of like a spider web network, but it will be a solid part once it's done. We can export it as a step file, we can extrude into it, we can cut holes into it, or we can extrude out of it. The most common use for this is for reference. So if I wanted to make a bone guide, for example, I could use this to make a bone guide. So I'm going to go ahead and hide my mesh by right-clicking here and turning it off or selecting hide. And we can see the underlying model. It's quick, it's simple, and it gives us something that we can export as a step file, or we can work with it inside SolidWorks. This is a much easier file type for SolidWorks to work with. So that's our first demonstration. Now I'm going to go ahead and open up a new instance, or a new part, and I'm going to do the prismatic reverse engineering. Again, I'm going to go up to the left-hand side, and I'm going to select import. And then I'm going to select the correct STL. So again, we have a really nice mesh. This is something that we can get out of our HP scanner. I do have one small hole in it, but in this case, I'm not worried about having a watertight mesh because I'm going to prismatically reverse engineer it. If I turn on my planes, I can see that it's not in the correct orientation. The scanner knows where it's at in space, but it does not know where the part's out in space. So oftentimes you'll see something like this. So our first job is to get this into the correct orientation. So I'm going to hide my planes really quick, and then I'm going to set up some reference geometry on this so that I can align it to the global origin appropriately. My first plane is going to be on the bottom of this part. So I'm going to come up to the Geomagic for SolidWorks plugin, and I'm going to select Extract Reference Plane. Then all I need to do is select the bottom portion of it. It highlights red and gives me a preview of what the software is thinking I want. And in fact, that is what I want. So I'm going to go ahead and hit the OK option there, and that gives me a plane. Next, I'm going to go normal to the plane by right-clicking, selecting normal. Oh, and it looks like the normal is inverted, so I'm going to change the direction. I'm going normal 2 again. There we go. And now I'm going to draw a symmetry plane. To do that, I'm going to come up to the Extract Symmetry Plane option in Geomagic for SolidWorks. Then I'm just going to click somewhere in the middle and draw a line down the middle. What's happening underneath is it's taking this line as a reference and then subdividing the mesh to come up with a symmetry. So I'll go ahead and say OK. And you see that it kind of popped over into the middle of the mesh there. The last thing I'm going to do is I'm going to put a point right in the middle of this so I can have my origin be right in the middle of that circle. So again, I'm going to go normal to this point. So I have a top-down view. I'm going to zoom in a little bit. I'm going to say Extract Reference Point, and I'm going to put it right in the middle. Say OK. Now that I have all my reference geometry on this mesh, I'm going to send it back to the global origin. To do that, I'm going to come up and select Orient Mesh, and then I'm just going to choose the reference entities that I want. So I want this point 1 to be my global origin, and I'll say OK. Then I'm going to choose in the y-axis, I'm going to choose plane 1 so that my y-axis is pointing upward, and right now it's pointing downward, but I'll hit this reverse arrow so that it's pointing upward correctly. And then in my x-axis, I want my symmetry plane to be to guide my x-axis. There we go. So now this is giving us a preview of where the global origin is going to be, or where the part is going to move to. So I'll go ahead and say OK there. And it'll move the mesh to the global origin. At this point, I can delete out this reference geometry because I no longer need it. So I'll just right click and select delete. Now I can turn on my top right and front planes again and verify that it's in the correct alignment. Once it's in the correct alignment, we can actually start reverse engineering. So again, I'm going to select normal 2 on my top plane. And there it is in the global origin. Okay, so this is a very organic surface. So the way that I'm going to remodel this part is pretty simple. Basically, I'm going to put a free-form surface on top of here. Basically, you can think of it as dropping a sheet over the top of this part to make a good representation. And we can adjust the settings so that that sheet fits as tight as possible. To do that, I'm going to first turn off my planes. Then I'm going to go into Geomagic for Solidworks, and I'm going to select Extract Freeform. Then I'm just going to highlight this area, and maybe a little bit more. And then I'm going to turn up my accuracy a bit, and I'm going to say OK. This is going to put a freeform surface down on it. Oof. I think I might have had a graphical issue. But once we have that surface, then we can go on to the next surface. So to create this simple surface, or this flat plane surface, I need to go into SolidWorks itself, select Sketch, select my base plane, and I'm just going to draw a quick rectangle on there, something larger than the model itself, and say OK. I'll exit out of my sketch. Then I'll come up to the tools. I'll select, insert, and then I'll surface. Then I'll select planar surface. Choose my sketch and say OK. Ooh. What happened? I'm going to try that one time, and if that doesn't work, I may have to reopen the software because I'm having some sort of graphical problem. Okay, I got the surface, but I'm still having a graphical problem. Okay, so bear with me for a second. I'm going to go ahead and shut down SolidWorks. Then I'm going to reopen up SolidWorks and try that again. The intention was to have those two surfaces, and then I could use them as cutting and merging. So then I would then have that enclosed CAD part. After that, I would have created the tab. And let's try that one more time. This time it should be just a little bit quicker. So I'll come up to import. I'll select the metal part, open that up. There's my part. Then I need to extract a reference plane here. Perfect. I need to come up and tell it to be normal 2. Then I'm going to extract a symmetry plane down the middle of portion. Okay. Then I need to put a reference point right in the middle of that circle. And this will be just a little bit quicker than normal. I'll say OK. Now I'm going to come up to Orient Mesh once again, and I'm going to use those references to align. Global origin, y-axis, inverted. Make sure that's appropriate. There we go. And my x-axis is going to be my symmetry plane. Perfect. Once again, I'm going to remove all these. so I no longer need them. Now I'm going to put down the surface. So again, I'm going to select freeform surface. I'm going to highlight this entire body. Good. Make sure all my settings are appropriate. And then say OK. So it's going to take a little bit of time to think. There we go. That's better. So now we have a surface that's fitting over the top of this. And if I hide my mesh, we can see that we've got that nice contoured surface all around the top of that part. The next thing that we need to do is create that bottom surface that I attempted earlier. To do that, I'm going to hide my surface that I just created. Come down to the bottom side. Oh, I'm sorry. I'm going to go into the sketching, select sketcher, select my base plane. Then I'm just going to draw a quick rectangle around the bounds of the car, or around the bounds of the part, rather. I'll say OK there, and then I'll exit the sketch. Then, still inside SolidWorks, I'll go up to Insert, select Surfaces, select Planar Surface, and create a surface off of that sketch. Now I have two surfaces that are intersecting each other, and then I can use them to cut one another to create that part. So again, I'm going to go into Insert. I'll select Surfaces, and then I'll select Trim. And then I need to adjust a couple settings. I need to make sure that my trim type is on Mutual and not on Standard. And then I can select both this square surface and this freeform surface. Then I can come down, and I need to make sure that I have this on Remove Selection. Then I can highlight the pieces that I don't want to keep. And that's going to give me just that internal cavity there. I'll then make sure that I have it on Create Solid, and I'll say OK. And now, if I open up my solid bodies, we have solid. If I hide my mesh, we can see what that looks like. So at this point, just to create that back tab. And the way we're going to do that is we're going to take a sketch as a reference from the mesh. So I'm going to go ahead and hide my surfaces again. And this time I'm going to turn on the bottom surface. Or I'm sorry, the bottom plane. I'm going to go back into Geomagic for SolidWorks. And this time I'm going to say, I'm going to tell it to take a cross section off of this base plane. So I'm going to zoom in here, and what we're going to see is when we push this mesh, when we push this up into the mesh, it's going to give us a reference line anywhere that the plane is intersecting the mesh. Tell it to go this way, and I'm just going to type in, I think 0.5. Maybe let's do 0.75. 0.75. So here, if I zoom in, you can see the intersection line along the mesh. So I have three different things that I can do here. I can create reference geometry or polylines. I can create lines and arcs, or I can do splines. I'm going to create just polylines as a reference, and then I'm going to go in and edit it and create my own kind of sketch. So I'll go ahead and say OK there. I'll hide my mesh, and I'll edit the sketch that I just created. I'll go normal to the surface. Ooh, how do I go normal to it? There we go. And then I'll zoom into the area that I want to work in. And here, it's basically just putting lines and arcs on this construction line. So there's one. And there's two. And I'm going to put a center line in the middle, and then I'm going to use that to mirror the opposite side because I don't know if I trust this side to be as square as I want it to be. So I'm going to come up to the mirror entities, and I'm going to select my entity to mirror, and then I'm going to select my mirror outline, and that's right where I want it. So then I'll say OK. Then all I need to do is draw one more line inside the model. And then I need to connect them all together. And to do that, I'm going to go into Trim Entities, and then I'm going to select Corner Trim. Trim here, trim here, trim here, and trim here. The last thing I need to do is adjust these two fillets. And to do that, I'm going to come up to the fillet command, select this one. And we can see that it's not 0.10 inches. It's probably somewhere around 3 or maybe 4. There we go. Then I'll select this side as well because I want it to be symmetric. I'll then say OK there. And then at this point, it's just a normal extrusion. Say OK to that command. I'll exit out of my sketch. Come back out. And then I'll extrude this. Go into the features. And as a reference, I'll turn my mesh back on. Go extrude, or select extrude, and then select my sketch profile. I want this to go in the other direction. Then I want it to come out a certain distance. And it looks like, let's put it at a round number, and we'll put it at 2 inches. And I also want it to go down to the bottom. So I'm going to select the second direction. Instead of blind, I'm going to tell it to go to this surface. I need to turn on my surface first, or I need to unhide it rather. Oops. I'll just put in 1. Perfect. There we go. I'm going to have to adjust this in just a second. I'll go ahead and say OK there. Unhide my surface, hide my mesh, and then adjust my sketch so it's planar. So again, up to surface, select the surface, say OK. And the last thing I forgot is I need to merge these 2 options together. There we go. Perfect. So now we've reversed everything except for the hole that we have in the middle here. And that's our last step. So again, I'm going to turn on my mesh. And I'm going to take another sketch off the same base plane. I'll go up to Geomagic for Solidworks, select cross section, and select this plane. Then I'm going to set this up maybe 2 millimeters so I get that hole. So I get a cross section in that hole. Cool. And I will say OK. I'll go back in, edit that sketch, and put down an actual line and arc in there. We'll just use a circle, and I'll snap it to the outside. I might have to adjust that. Delete. And say OK. Exit out of my sketch. And then at this point, it's just a simple extrude cut. Highlight my mesh. Or I'm sorry, highlight my sketch. Make sure that it's protruding through the solid body. There we go. And cut. Hide my mesh. And now we have a prismatically reverse engineered part from our mesh. And with that, I'll go ahead and hand it back over to Alex. There we go.
Thank you. That was awesome, man. Great job. Holy cow.
No problem.
All right, cool. So let's see here. I'm going to try and switch back to being the host. All right. We'll see if we can get this screen share going on again. All right, perfect. You guys able to see the screen again?
We are.
All right, beautiful. So thank you very much for that. I think you really did a fantastic job showing the broad range of capabilities. And I know we really just touched on the surface of what can be done with the Geomagic plugin for SolidWorks. But I think that was a good example, particularly with that car part at the end there. You know, that's definitely the type of model that I think as an engineer, you know, if you were tasked with reverse engineering that without 3D scanning, it would be pretty darn tough. And even with the 3D scanner, without having something like Geomagic, that's really a lot of like lot of curves and surfaces to try and recreate manually. And you were able to show how quickly you could do it. I mean, given that, SolidWorks took a little break on us there in the middle, and you're able to kind of start over and get it all done so quickly, I think that really does showcase the strength of the software. So some things that I think you probably mentioned all these along the way, or they came up in the presentation, but I do want to summarize a few tips and tricks for everybody here. So the first is that in general, 3D scanners are not created equal, right? There's different technologies, there's different price points, there's different qualities. So, it's important that you understand what it is you're starting with from the data when you're working with the 3D scan. A scan off of an iPad, for example, or a cell phone is totally different than a scan off of an industrial scanner like the HP scanner. Secondly, when you're working with the scan data, you do want to have as good of a mesh as possible. So I think you showed clearly how easily you're able to convert, let's say, that super organic shape, like that bone component, into a solid model when you start with a really clean mesh. Now, of course, we do have mesh repair tools in the plugin, but the way I like to think of it is, I'm very much into photography, and certainly you can fix a photograph, in Photoshop, but you're always better off getting the highest quality photo possible, in the camera. It reduces the amount of post-processing time, the amount of work that needs to be done. So when we're doing scanning, we always like to remind people, think about the mesh size and the resolution, focus on reducing holes and noise during the scanning process as much as possible. As you showed today, we can work with data that has some holes in it. We can do repairs on it. But the more that we're able to repair beforehand or to identify beforehand, the better. Sometimes in scanning, a foreign object might get in the scan. Maybe it's your thumb. Maybe it's something you left on the tabletop. If you can remove those things during the acquisition process, that's certainly going to speed things up. And of course, looking at lighting and controlling that in your area, that can eliminate things like spikes in your scan surface or anything of that nature. Third, STLs in general don't import super well into most CAD systems, and that's not your fault. Sometimes people feel like, they're doing something wrong and they search the internet. Looking at an STL file, it is super easy to create from CAD, but it's super difficult to import in. That is normal and predictable, and it happens to everybody. So, the beautiful thing here is, number 4 is that really 3D scan data does require some type of conversion to get it to work properly in CAD. Now, there's some brute force methodologies you can use, but we find that the Geomagic for SolidWorks plugin is really that secret sauce. That's what's going to allow you to quickly and efficiently move through the scan. I've worked with customers who've worked days or weeks to try and recreate the type of data you were able to do in minutes using the Geomagic plugin. We find that usually the fastest and easiest way to just quickly get 3D scan data into something useful in CAD is to do what you showed first, which is that NURB surfacing functionality. It's almost like a one-button touch. It's pretty simple, and it does give you a model that you can cut holes and cross sections and use to cut surfaces and things of that nature away from other objects. And so we find people really do like that. Of course, the best technique is what you showed on the car model with that full design intent-based reverse engineering. And a really cool thing about that approach is, let's say that you didn't even want to recreate that tab, or you wanted to change the shape of that tab. You absolutely could have done that. You're not constrained by the scan data. It's just a reference for you to be able to build on top of. And 7, this one is maybe the most important as you're working with your team and setting expectations on how you do 3D scanning. We always say that post-processing is going to take at least the same amount of time as it took to acquire the data. So, if you spend, let's say, an hour acquiring a scan, you should plan for about an hour on the back end of working with that file. Now, of course, if you're going to have a super complex model with hundreds and hundreds of features, that rule may go out the window, and it may take longer to reverse engineer. But we find that's a good rule of thumb and a good way to set expectations with folks as you're approaching 3D scanning projects. Now, I know we're a little bit over time here, so I think I'm going to breeze through the question section here. I haven't seen anything coming through from folks yet, but if any questions do come up, what I'll do is reach out over email, and we'll be happy to work through those with you guys. Thank you all very much for your time. Jeffrey, especially, thank you for joining us. It was a special treat to get your experience here and to be able to see that. If anybody has any, thank you. If anybody has any questions about what we saw today, either the scanners or the software, please feel free to reach out to me directly. This is my email address here and my office phone line. That's my direct line. I've even got my cell phone on there, so if you want to shoot me a text or something in the future, we'd be happy to work with you. So thank you all very much for your time, and we look forward to working with you soon.